Hi everyone. I am Mael Charpentier from the University of Montreal, and so I will talk about the optimal sensor placement in urban environmental monitoring. Okay. So more precisely, I will look at the safety, the population safety in a dynamic environment, and so we want to know when do we need to say the population that they need to leave their home, and also when they can come back, especially, for example, if we have a wildfire. One simple case is you have a fire at your door, then you need to leave, but also you have some things that you cannot see, for example, the CO2 or the fine particle. And so when are these metrics too high and that you need to leave your home? And so it is in that we are interested. So what we would like is to place a sensor everywhere, but we can't. Mostly because of cost, but also because sometimes the rent doesn't allow us to place sensor at some place, and so we are limited with a small amount of sensor, and using this small amount of sensor we will have only a few measurements, and we need to make estimates that are pretty good and that we don't make a mistake to say that you can stay while, no, if you stay, you will die. So we need to have a good pipeline to say, right now, we will place this sensor here, we will do this type of prediction, and then yes or no, you can stay, and when you can come back. And using this small amount of sensor, how do we place it? Because if we place it somewhere completely random, then the measurement that we will get is not good, and so the estimation that we will do at the place where we didn't place a sensor will also not be good. So we we have a lot of trade-off at a lot of space, and so we need to conceal all of this point. And so our approach is based on two things. First of all is an optimization algorithm that will determine the place where we need to place sensor, and for this we will use the information theory, especially entropy or mutual information, to know which place gives us the most information, and so we know that the information that we will have will be good, and so the extrapolation that we will do will normally also be good. And then once we place the sensor, we need also a model to be able to do the extrapolation, and so for this we will use some machine learning model like Gaussian process training to do the extrapolation integrated with physics-based model. And the goal is to maximize the information but also minimize the uncertainty, especially in a critical area. And so a small example, so the one that I gave before, so wildfire. So we will want to predict the CO2 and fine particle to be able to compute the air quality metrics, and then know when it is too high and so the people need to leave, and we will need to do this, we will need that our air quality metrics to be to have a high confidence, such that when we say that yes, it is safe, it is around, for example, 50, that you can stay. But if it is false and then it is not around 50 but 500, then the people say maybe not die here but be pretty injured. So it is what we want to do. And so it is what my research is around. Sorry. And so the application, like I say, is fire, but also the pollution or industrial risk like mine. And the next step is, right now we are only using a fixed sensor that we will fix at some place, but we can also use some sensor, mobile sensor like a drone, but also, for example, integrate a satellite, because I talk about the fine particle and CO2, but I also said that if the fire is right here, then you need to leave. So we don't have access to this right now, so it is something that we would like to add into our pipeline. Thank you.